Good afternoon, everyone. Welcome to the Bioinformatics Lunch and Learn webinar covering command line analysis with Cromwell and PacBio SMRT Link 8.0 software. I'm Matt Seetin. I'm the Bioinformatics FAS covering the West, and I'll be getting going in just a minute or so to give folks another opportunity to join in. Attendance looks good, and we know a lot of people are planning on just viewing the recording afterwards, so we want to get going in a timely fashion. All right, let's go ahead and get started. While this webinar is primarily targeted at existing SMRT Link users who are looking for the latest information on the many major changes in our latest release, I would hope that it is accessible to new users as well. I'll begin by covering a bit more than just how the PacBio software development team has implemented the Cromwell workflow engine as a replacement for pbsmrtpipe. Along with that change, we've made some other major changes, including to the CCS executable to help users who run CCS that way, and a PBSERVICE that functions as an interface between the command line and the GUI for users with a full SMRT Link installation, but who also like to use the command line. Finally, we'll go through where to find your relevant output files on the command line, as our output directory structure is substantially different. And I'll show you how you might go about getting started with running your own custom workflows with Cromwell. While we cannot offer comprehensive support for users who engage in this, we know that Cromwell is a widely used workflow engine, and that many people in our user base have experience using it to drive their own tailored analyses. Thus, I do want to put out there what people can find in the Cromwell, where people can find the Cromwell workflow templates that drive our supported workflows, so that anyone can use them as a jumping off point for tweaking one of our pipelines for his or her own needs. First off, I want to introduce or remind everyone how to set up the command line environment. The good news is that for existing users is that this is unchanged, and for new users, it's very easy. All that is necessary in your environment to run workflows end-to-end with PBCROMWELL is having the smart commands bin directory in your path environment variable. While defining a smart root environment variable is a recommended convenience that can make copying and pasting syntax provided in our documentation or slides easy, it is ultimately optional. Before getting into running our end-to-end workflows, I first want to offer an update on the CCS executable, as we know that many users simply run the CCS executable directly upstream of their other analyses, and that may be for them the extent of their interaction with our software. The most exciting feature of the latest release is definitely the further speed up by approximately 4 to 6-fold. But in addition to that, I want to mention a new feature that wasn't as loudly trumpeted in our release materials, but is one that I still find to be a newsworthy convenience. The latest version of the CCS executable can now accept a -- chunk flag with an argument in the form of 2 integers I/n, such as 1/8 or 13/29. When supplied, CCS will then, as one would likely intuit, calculate how to divide the input data into n roughly equal chunks, and it will operate only on the ith chunk of the data. This makes manual distribution of the job across n nodes extremely easy, as long as they can all access the data on a shared file system. Other than this addition, the syntax for the CCS executable is essentially unchanged. Next, I'll take you through the PBSERVICE command. PBSERVICE is my preferred means of running jobs from the command line when there's a full SMRT Link installation available. Most of the functionality of PBSERVICE, such as importing datasets, is unchanged in SMRT Link 8.0, so I'm going to focus exclusively on the functionality pertaining to running our end-to-end workflows here. Jobs run via PBSERVICE give you the combined conveniences of command line execution and viewing the generated images in your web browser. PBSERVICE jobs Also use the job management settings established at the time of SmartLink installation, during which the SmartLink installer works to walk you through cluster setting choices and automatically detects things when possible. I generally find setting things up this way easier, and once done, it saves a step relative to running via PBCROMWELL, which we'll see in a moment. Running a PB service job does begin with executing PBCROMWELL, however. I'll break these two steps down in greater detail when we talk about the PBCROMWELL functionality in particular, but they should feel familiar to users of PBSMRTpipe. PBCROMWELL show workflows has replaced PBSMRTpipe show pipelines, and likewise for PBCROMWELL show workflow details. We use the show workflows mode to get the internal name of the workflow we wish to run. In this case, we want to run CCS, which has the internal name PB_CCS. And then we use show workflow details to simultaneously display the list of necessary entry points, show the default settings, and emit a JSON file of those settings should we wish to change any. With that in hand, and knowing the path to the subread set we wish to analyze, we are ready to run. The syntax for PB service is essentially unchanged from previous versions of SmartLink. Adding the PB service host and port to your environment variables will shorten the list of arguments you'll need to specify when running in this way. Another way to run via PB service with even shorter syntax is via job.json files and the run analysis mode. The easiest way to get an example job.json file is with the PB service get job functionality and the job number of a previously run job of the same type you wish to run. In this case, we've queried job 1, 2, 3, 4, 5. The job.json contains the workflow name and all the settings used. These settings can be edited as you wish. Note that the input data here is listed as a dataset ID, in this case 72303. If you wish to run in this fashion, you will need to run on data that has been imported into SmartLink and thus has a dataset ID number. For users who may have used the run analysis functionality in previous versions of SmartLink, the job.json file here is not as extensive as in previous versions, and it doesn't break down the workflow in a way that would be editable. That information is all in separate cromwell.wdl or WDL files, and we'll be examining those coming up. Part of the reason why I like PB service executions over PBCROMWELL is because I'm human and I forget things from time to time, and we have a new mode of PB service tailor-made for the occasionally forgetful people like me. Since we've dropped support for SmartView and instead point users to IGV for visualizing their aligned data, we have a flag in relevant analysis jobs to turn on consolidation of the BAM file for visualizing in IGV. It is off by default to save storage space, but users will often want to turn it on for visualization. People like me will forget that here and there, but rather than needing to rerun the job or do a more clunky manual consolidation, PB service consolidate BAM saves the day. This can be run either on a job that you ran from the GUI or from a PB service job, but not from a job executed via PBCROMWELL. Also note that this only applies to aligned data, so it won't consolidate data from a standard CCS job, only, for example, a CCS mapping job. Having trouble with your job? Depending on whether you suspect it's the job or your cluster configuration, you can send us the essential files so we can see how to help you. The workflow here is first to send an email to support@pacb.com. You'll get a case number in the email, and that serves as the case number in the comment field there. We need this case number to match the submitted log files with the user who is seeking help, so transmissions without a case number may be ignored. If you want information about the additional modes in PB service, run pbservice-help. PB service is a bit of an exception in our software suite in that it requires a --help to get help and not a single -h. But it'll break down much more available functionality than fits in the scope of this webinar. Okay, let's break down running via PacBio's wrapper around Cromwell, PBCROMWELL. Our developers wrote a modest wrapper around Cromwell for the purposes of running our workflows. The main purpose of adding the wrapper is to save one execution compared to how standalone Cromwell is run, thus making the process of starting a job feel more like PBSMRTpipe. PBCROMWELL, like most of our tools, has many modes, and you can get the list of them all by running pbcromwell-help. For help on a particular mode, run pbcromwell in the mode name. In this example, we're in run mode, and then we add a --help. Do please note here that there are some errata in the help that appear this way. The syntax in this presentation is correct, and I'll highlight where the command line help is incorrect. Also, we'll be releasing updated documentation and a troubleshooting guide with a correct syntax in the very near future. I mentioned PBCROMWELL show workflows in the last section. Let's take a look at what that looks like. Here we list the available supported workflows. In SMRT-Link 8, when specifying a workflow, you need only specify the suffix, such as pb_hgap4, and not the whole dot notation name, like cromwell.workflows.pb_hgap4. Also bear in mind that two workflows with the same name in plain English may have different workflow names due to different inputs. We have two workflows labeled structural variant calling, but they take either CLR or CCS input as indicated in the workflow name. The extra step and eventual extra syntax of PBCROMWELL relative to PBSERVICE is the Cromwell backend configuration file. Without this file, PBCROMWELL will only run local jobs. Generating this file is easy by running PBCROMWELL in configuration mode, in configure mode with the syntax you see here. Do note that the default backend syntax shown here is correct. Other places our documentation show simply a backend flag, which is incorrect. In this example, we use SGE, but in addition to SGE, we can generate files for Slurm, Torque, LSF, and of course local jobs, which is the default behavior of PBCROMWELL configure if you don't specify a default backend. If you edit one of these files, you may also see references to running on AWS. That is not a ready solution at this point, but I won't stop a user who is experienced with running Cromwell on AWS from tinkering. Speaking of editing the cromwell.conf file, the generated file may work without editing on your cluster, but you may need to work with your IT people in order to arrive at settings that fit how your cluster allocates its resources. In my opinion, however, creating this file and running with it is much easier than the prior solution we had with standalone pbsmrtpipe to run distributed jobs. Moving on, the show workflow details step here is essentially identical to what we saw with PBSERVICE, and our entry point syntax is identical to what users would be familiar with from pbsmrtpipe. Supply a -e flag and a path to a relevant subread set, reference set, and/or barcode set, XML file, and you'll be ready to go. The nproc flag here is the number of processors per concurrent task, not for the whole job, so be mindful and don't request too many. Of particular note here is that for the --config flag, where we specify the cromwell.conf file, specifying the full absolute path to the cromwell.conf file is required. Running with a relative path, as in the examples in the command line help, will fail with a file not found error. Relative paths for all the other input files are acceptable. Let's take a look at an INPUTS.JSON file. The one from CCS is really simple and seldom needed, as the default parameters for CCS are what are used in the vast majority of cases. So I've chosen HGAP4 for further scrutiny. As you can see, the syntax isn't exactly plain English, but it's not too hard to decipher. Each of these parameters correspond exactly to one of the required or advanced analysis parameters that appear in the HGAP4 job in the GUI. So the tooltip help there is one easy way to get further information about these settings if you don't have our documentation handy. One thing to note, PBCROMWELL documentation makes reference to being able to tweak a single parameter via a -t flag in the command line execution. This is possible for most workflows, but it is a known issue that it doesn't work for HGAP4. In general, I prefer to supply the custom parameters via the INPUT.JSON rather than the -t flag so that I don't have to remember the dot notation parameter name. So that's the workflow I've laid out in all of these examples and it's the one I use for all workflows. Let's take a quick look at running an HGAP4 job, since most of what I focused on so far is CCS. For HGAP4, the workflow name is pb_HGAP4, and the process of generating our input files is otherwise identical. We'll edit two input parameters, the Falcon config overrides and the genome size. In general, I don't recommend that novice users tweak the Falcon config overrides, but we've done so here just for illustration. Most of these are the default values anyways. With those edits, we can now elect to run via either PBSERVICE or PBCROMWELL. By now, I've set my environment variables to shorten my PBSERVICE syntax. When executing with this syntax, the PBSERVICE job will be written to the jobs root folder in the SMRT directory in numerical order. The PBCROMWELL execution will be written to the present working directory. That can be changed with a flag if desired. Let's take a look at those output files. Looking inside a job folder from a PBCROMWELL or PBSERVICE job should look familiar to pbsmrtpipe users with two key differences. Entry points and logs are essentially unchanged. The workflow directory is still there, but it now has a lot more data in it, including additional metadata and information about the timings of the run. Of the new directories, outputs is obviously the most useful. We now consolidate selected output files in the outputs directory rather than making command line users hunt through tasks. Do note that many of the things found in outputs are symbolic links to the outputs rather than being the outputs themselves. So take care when doing further operations on those files. Which files can be found in this folder? The short answer is that it's the same files that are made available for download from the SMRT GUI, or those that are listed in the Smart Tools reference guide. If you wish to examine other intermediate files, you'll need to take a look in the Cromwell-job folder. Let's take a peek inside. The Cromwell-job directory is generally quite a bit less cluttered than the tasks folder from pbsmrtpipe jobs. This is mostly because chunked tasks are stored as subdirectories of one of these tasks rather than all being listed on this level. In this example for CCS, we see a relatively modest set of tasks, but each job has a unique set of associated tasks and may be much larger for more complex workflows like HGAP4 or microbial assembly. Tasks labeled gather or export or report are likely to be ones where the genuine versions of the desired output files live. In general, if you knew where your desired output file could be found inside a pbsmrtpipe task, there's almost certainly an equivalent folder for it here, but it may be a subdirectory and it will definitely have a different name. The tasks that get executed here are essentially in one-to-one correspondence with the pbsmrtpipe tasks, however. All right, it is caveat time. Everything else in this webinar that I'll talk about is unsupported, at least until we get to the questions section. However, something being unsupported doesn't mean it should be secret or unused. We generate a number of useful features that are unsupported, but they are still quite useful in capable hands. We just can't support your custom workflow, so it's on you if you can't quite get this to work. Cromwell parses workflows from .wdl or WDL files, and anyone who's worked with Cromwell prior to or outside of SMRT 8.0 would have encountered them before. And you might expect that each of our supported workflows has its corresponding WDL file. That's true, but they're a bit hidden. I've put the path to them here for you to see in the webinar. They are bundled up along with a fair number of internal or developer or constituent workflow WDL files. Inside one of these WDL files, I've chosen CCS, for example, naturally. The syntax is pretty clean and easy to understand. In the screenshot, you can see the default parameters and the calls to update, filter, split, scatter, and then run CCS. Not shown are the gathering and the generation of reports, generation of fast A's, and generation of fast Q's. It does seem quite ripe for editing, but I'm not going to guarantee that it's exactly that easy. If nothing else, if you want to make 99.9% accuracy the new default setting instead of the current default of 99%, that is easy enough to change here, so you won't have to supply an INPUT.JSON every time. All you need to do is add a 9 and save the file. Bear in mind that this WDL file has 4 others it imports, so be careful if you start moving these files around. The Pandora's box of potentially tacking on calls to non-PacBio software, I'm going to leave as an exercise for our most adventurous attendees. Running custom workflows via PBCROMWELL is practically identical to running supported workflows. Rather than specifying a supported workflow name, instead supply a path to the WDL file. In my example, I omitted the INPUT.JSON based on the assumption that you set your parameter choices in the WDL file itself. Thanks for attending, everyone. I'll now field questions, and feel free to type them into chat, and we'll answer everything as best we can. If you wish to stick around, but also if you need to dash off and get your analysis job started, I'll certainly understand. First question, is PBCROMWELL open source? No, it is not. To the extent that Cromwell is open source, you may be able to review those portions of it, but the wrapper around it is not open source. Question, do you have a workflow that pulls out the files from a SMRT-Link job based on the job number, since the symbolic links make it difficult to share the output files from, say, an ISOSEQ job? To the best of my knowledge, no, but that's one I'll have to check with our development team if there is perhaps a developer workflow that's not one of our most prominent end-to-end workflows. As a stopgap solution, you should be able to bundle up the entire job folder and send that, which admittedly does send a lot of intermediate files, but it does guarantee that you send the true output files along as well. Our next question, does or can PBCROMWELL use the pre-configured cluster settings that SMRT-Link has? The answer to that is actually no. The cluster settings that SMRT-Link writes as part of its installation process cannot be supplied to PBCROMWELL using the -- configure flag. The two have different formats. That's generally why I recommend using PBSERVICE to run command line jobs if you have a full SMRT-Link installation that is working for you. To set up the files for PBCROMWELL are in a different format, and you'll need to set those up especially. Question, are the WDL file workflows bundle with PBCROMWELL available to run outside of PBCROMWELL or for customizations? I have not tested running our own WDL workflows via regular Cromwell and not PBCROMWELL. That's one I don't know. You certainly can run customizations within PBCROMWELL, but that's one I just haven't experimented with. Follow-up on the ISOC question is that bundling up the entire analysis job does include the giant scrap spam file. Yes, that can be an inconvenience. So I'll definitely have to check with our development team for a more elegant solution to just extracting the preferred output files. Next question is, just like PBSERVICE, is PBConda Python also well supported? If yes, then we can create other workflows such as using SnakeMake. Let's see, so the PBConda is, if that refers to our Bioconda installation, that software is actually unsupported, and PBSERVICE is entirely separate from our Bioconda software. And generally, PBSERVICE is not going to work with running those. So you may be able to use SnakeMake with the Bioconda software, but that's going to be kept separate from PBSERVICE. All right, folks, I think there seems to have been at least a pause in our questions. I will stay on the broadcast for another minute or two in case they come in. But for anyone else who was hanging out to see if there was anything that any insightful questions from our user base that might help them out that they didn't think of, this seems to be the end of the questions that we've been getting so far. Thank you very much for attending, and best of luck with your analyses. All